Hey class, how's it going? We've got our two body problems this week that we've been kind of going through. This is similar to some of the two body problems we did last year. I'm adding something this year in grade 12 that we didn't do so much in grade 11, which is our tension. So basically, I didn't do too much last week because there's a lot of force applied, but it doesn't technically include ropes all the time. When we're doing two body problems, it includes a lot of ropes, so I thought I'd include tension in here. Not that we're probably gonna have like tension on a lot of our exam stuff or those possible optional exams, but let's go through because it is a good important part of what we're doing for our forces unit. So, what is tension? Tension is basically just, it is the force upon, like the force on a rope or upon a rope to actually pull the object. So it is a force, okay? And so the annoying thing, there's no perfect, exactly tangible formula, but the biggest thing we're going to do is like, how do we find force? Force is mass times acceleration. And so torque with a big T, sorry, tension, not torque, please don't get those wrong. Tension is also mass times acceleration, okay? So we're going to use this as basically our formula, but we're going to have to tweak with this right here, okay? And the reason we're going to tweak with acceleration is because there's possibly two accelerations, gravity as well as how fast the actual system, I'm going to call it the system of objects, is going. So let's kind of go through an example here of what I mean by this. So on one of your simple questions, we have something like this. We have a pulley, we have a rope, and we're going to have two different masses. Okay, 6, and let's call this one 4. So from our simple two-body problems, and 6 and 4, I mean kilograms. 6 kilograms, 4 kilograms. You can kind of guess here that, again, the 6 kilograms is going to be, I dropped it, is going to be winning. So this is going to be going down. So now if this is going down, what is the force on the rope? Well, it's going to be pulling this. Like the tension, I like to draw. That's what tension, that's the force it's going. Tension is going to be pulling this. Okay? So the tension, let's just look at our formula. Again, mass times acceleration. Well, we have our mass. This is pulling the 4 kilograms. So it's just me pulling the 4 kilograms. So all we're going to do for our mass is 4. Now times. Well, we've got a little work to do here. Okay, let's actually figure out the actual acceleration of this actual thing. So I have a force here. I have 6 times 9.8. For the force of, we're going to call this A, and this B. So force of A equals, and I actually don't have this on me right now. Where's my calculator? There it is. Okay. Let's do this. 6 times 9.8. We have 58.8. 58.8. And for force B, we have 4 times 9.8. 4 times 9.8, we have 39.2. 39.2. If I want the net force, right over that here, net force equals just these minus each other. 58.8 minus 39.2, I get 19.6, which is awesome. And then to actually get the actual acceleration of this whole thing, just divide by the total mass. So I can do this, divide by 10, my acceleration equals 1.96. Okay. So I have an acceleration of this thing of 1.96. Problem is I'm not just going to put 1.96 in here. Okay? Because what else is acting upon this, basically? Like, if you were to just imagine just this rope by itself, okay, from right here down. If there was nothing pulling, what's the tension of the rope? Well, it's going to be the mass of 4 times 9.8, because gravity is pulling it down. Okay, so that would be without this. Now that we have this also pulling it up, there's going to be that extra tension. So my acceleration here is going to be gravity, because I'm going against gravity. 9.8 plus 1.96. Okay, once you add those together and multiply it by this mass, that's going to give you the tension. So let's do that while I got a second here. 4, let's go, 9.8 plus 1.96 gives me 11.76. So 4 times 11.76 times 4, I get a tension, 47.4. And that is for this whole rope. This whole rope is feeling a force of 47.04 newtons because it's pulling this. This is what's going down, which means we don't really, the rope doesn't feel the 6. It's having to pull this up. And because it's going against gravity and has its own acceleration, we're plussing those. Okay? So here's one example. I will do another video with 2 more examples talking about tension. But again, just think of the intro and just think of our basic, what is tension? Tension is the rope pulling on something else and what that force is needed to pull on it. The annoying part again is like the simple formula is tension equals mass multiplied by acceleration. But acceleration can be a little tricky because sometimes we're going with against gravity or with gravity. So yeah, a little tricky unfortunately sometimes. But there's only really 3 scenarios that we're using, this being one of them. And then I'll go over the other 2 scenarios in the next video. All right, thanks class.